Welcome to CNC Motion. This is the software that you use when you want to cut a CNC part using the mill. And as you see, the way it's set up, you have your menus across the top, you have a set of buttons across here. This is your 3D image. To move your 3D image around, you have to right click in the box and then move your mouse around the table. That'll move the picture around. If you want to change the angle, you can move the slider up and down as well. Over here is the spindle on. These are accessories. This is the emergency stop button on the mill, and this simulates opening and closing the shield. Down here is your machine info. Right now I have tool 1 in the spindle. Tool diameter tells what the spindle speed is, and it tells what the XYZ coordinates are of where the spindle is within the work envelope right now. This is the verify window. This allows you to see what's going to go on the stock. This is your program window, and this is where you do your programming and write your program. Over here, just like the mill, it simulates the operator panel. It allows you to stop, start the program, override spindle and feed rate, and the jog control is right here as well. This allows you to move the mill, the spindle up and down, or in the x-axis or the y-axis. There are some very important menus that you really need to be aware of, and we'll go over some of the menus right now. File. When you want to start a new project, as if you wanted to start writing a program, click on New, and you'll get a new program window. Notice that it doesn't fit real nicely. Under Edit, if you run a program or verify a program, all of a sudden you won't be able to edit anything in your program window. You have to click on the lock. If you lock it, it'll turn gray and you won't be able to edit it. If you click on Edit and uncheck Lock, you'll be able to start editing again. So if your students can't edit their program, have them unlock it first. Under View, I like to always show the position. This shows the XYZ coordinates of the actual tool. In Program, after you verify your program, you'll be able to estimate the runtime. In Tools, we'll talk about this later, we'll set up a tool library so that you have all the tools that you need. Under Setup, there are some really important things in here too. When we set PRZ, or the corner of the block, on the corner of the block, we'll need to go to 0 position. Click on 0 position to set that. Run settings are pretty important. In run settings, when we click on that, it'll allow you to single step through a program. If your students are finding errors, they can single step through it to find where the errors are. Arc centers incremental should be checked if you're writing a program by hand. If EdgeCam is running a program, make sure that that is unchecked, like so. Otherwise you'll get bad arc errors. Never let a student run a program with bad arcs. Setup also has a spot where you can go in and change the size of the stock. If you decide that you want to use something other than a 2x3 block, you can change the size, and you do it here by changing the length, the width, and the height. 3D image allows you to change this image in the background here. Window is very helpful because you can move these windows around and it can get all messed up and you really can't find anything anymore. And all you have to do is go to the window and say Run and Edit, and it'll put everything in a nice neat organization where you want it. The first thing that you need to do after you open a new program, before you even start writing your program, is to set up your tool library. You only have to do this once, and what that does is that makes the library of tools that your students can use in simulation the same as what you have on the real mill right there in the classroom. To do this, you have to decide what your tool library is going to look like. And then once you decide what tools that you have to choose from, you go to the Tools menu and select Setup Library. In my classroom, we don't use Tool 00. Tool 00 happens to be the reference tool. Tool 1 in my class is an engraver. And I simulate that by using a tapered end mill and giving it an outer diameter of 0.0125, 16th of an inch. For simulation, that'll work just fine. Tool number 2 is an 1/8 inch end mill. And basically what you have to do, if you have nothing in here, what happens is these are blank until you put tools in. So let's say, for instance, for an example, tool number 10, let's say for instance that tool number 10 is a 1/8 inch ball mill. In order to make that be a tool 10 be a 1/8 inch ball mill, the first thing you have to do is go to tool type and click on ball mill. Then in the description, type a description. We said it was a 1/8 inch ball mill. I tell the kids to make the station number match the tool number, and in this case it really doesn't matter. That's for an automatic tool changer, but in their minds it solidifies it so that that's tool number 10. Put the number of teeth. This one has 2 teeth, and its diameter, don't forget to change the diameter. Make sure that it's correct, and in this case it is 0.125. Once you have your tool all set up here, and you can also decide what type of material it's made out of. Ours are high-speed steel. Click on the apply button, and then tool 10 is now ready to use. I don't have a tool 10, so I'm just going to leave that there. But my tool library consists of 2 1/8 inch mills, an end mill and a ball mill, 2 1/4 inch mills, an end and a ball, 2 3/8 mills, an end and a ball, and tool 8 and 9 are 1/2 inch end and ball. Once your tool library is set up and set up correctly, remember to check the diameter. For instance, make sure that the 1/2 inch end mill is really a 1/2 of an inch. Once all this is set up, you only have to do this once, you click on OK. And in between each of the tools, make sure that you click apply. Once you're all done, click on OK, and now your tool library is all set up. Now that my tool library is set up, I'm ready to actually go ahead and write a program. To do that, the first thing I need to do is say File, New. Before I do this, notice that whatever program you open last ends up opening first, and that's okay. It doesn't matter what it is. We're going to say New, and we have a plain blank program to start from. This is where the students start typing their program. They can start typing, and when they're done with their line of code, if they put a semicolon and type a remark, you'll see that the remark turns green. Remarks are green, code is in black. And this was just gibberish, so I can highlight that and delete it. I can copy and paste this. It's like a word processing. It works just like word processing. So I've already written a couple lines of code, and I copied them from the clipboard and I pasted them right in here. So here's my code. Notice though that I forgot to put line numbers in. You don't have to manually go and put line numbers in. You can do that very easily by going to the Edit menu and choosing Renumber. I like to start my code at 0 and increment in 5s in case I have to insert some more lines of code. And then click on the Do It button. And here they are. So it's put the lines, it's renumbered my code so that all my codes have a line number. And so I'm up to this point, and the student can now, if they want, they can go ahead and try to verify this code. Or you can wait till you get to the end. Now that we have our code all written, it's time to try to verify it in CNC Motion. That's what the simulation is all about. The first thing I want to do, this code that we just started from before isn't really complete. I have saved a program, and I'm going to open it. I'm going to say File, Open, and I'm going to choose this program, which is a fully remarked program to write the initials MD on the top of our piece of stock. Now that we're ready to verify, the couple first steps that we have to do, it's just like running the milling machine in the back of the room. The first thing you always have to do when you turn the machine on before you verify or run a part is to home the machine. And what homing the machine does is it basically goes up in the Z-axis until it hits a limit switch and it finds itself. It finds the X and the Y limits by hitting limit switches, and right here in the software it does the same thing. So it gets the kids used to actually homing the machine, and they have to do this every time so that the machine knows where its work envelope is. And to do that, it's very easy. You click on this Home button. When you click on the Home button and click Home, the machine will move up and back and forth. My machine happens to already be in the home position, so that it didn't move very much, but it's found home, so it knows where its work envelope is. It knows the positive X, positive Y, and positive Z limits. The next thing you have to do is tell it where the block of material is inside the mill. To do that, we have to find PRZ, or the corner of the block, which is right there. It's very easy in simulation. You choose the tool, Send Tool to Corner. If you click on that and then go Send the Tool to the Corner, click on the front left corner, it'll send the tool to that corner. Now that the tool is at the corner, we have to tell it that that's PRZ, or Part Reference 0. So we have to go to Setup, 0 Position. It's going to ask, are you sure you really want to set this to 0, 0, 0? And the answer is yes. So now we're all set. One place where you can get stuck here is if you accidentally, as you're doing this, if you accidentally click on the safety shield by mistake when you're doing Send to Corner, and I'm having a hard time doing it now, but if you, just like that, so if that opens, you try to close it over here, it doesn't close. So basically what you have to do is click around until you get the right spot on the safety shield, and it'll go up. It might take a little bit of clicking around. I don't know why, but that's just the way it works. So here we are. We found PRZ. It's now 0, 0, 0. We've saved that. So we've homed the machine, we've found PRZ, and we're ready to verify. Just as a quick review, before we actually verify this, I'm going to home the machine again, just to be safe. And this time you can see that the machine's actually moving. That's what the real machine will do also. And it will find its way on all the axes. And once it's home, we'll actually be able to go in and tell it where PRZ is by clicking on Send Tool to Corner, and click. The tool will go to the corner. This is one step the kids always forget. Go to Setup, 0 Position. You have to make sure that you make that the 0 position by saying yes. Now we're ready to verify. Really simple to verify. This is the Verify button. It looks like a piece of stock with a tool cutting the top of it. And all we have to do is click on this button, say Verify, and it asks us to insert tool 1 now. At this point, we have to either press F5 or click on the Go button. I'm going to click on the Go button, but before I click on the Go button, I want you to know that there are a couple errors in here. These are common errors that you'll get with your students. So once I've changed my tool, I say Go. Oh, I have missing numbers. And what the students will do is they'll click on OK. This box will disappear, and so will this blue line. This blue line is very important. That's the line of code that the error is on. And if you look down here, it says that line N30 has an error. Can you see what the error is? If I say OK and go to line N30, I notice that my M03 is an M03. So I'm going to change that to a 0. If the student can't make that change, all they need to do, if it doesn't allow them to type in there, is go to Edit and click on Unlock, which will be right here. It's not locked now, so there isn't a check mark there. So I've changed that to M03. I can go verify again. Let's see what happens. And also, before I verify, feel free to also open this window up. Since we're done with this screen, we can open this up and take a look and make this bigger. and say verify. Verify the program. Insert tool 1 now. Uh-oh, it made the first line, but now it says we're missing numbers. Okay, let's move this out of our way. Well, I guess we shouldn't have done that, huh? Move this out of our way. Verify again. Verify the program. Insert the tool. Oops. Line 12 has some errors. N55 has an error on it. Can you see the error? Let's go fix it other than the misspelling. That doesn't count. We'll say OK. We'll go to line N55 and see if we can find the error. Do you see where the error is? I think there happens to be a space where there shouldn't be. So let's remove that space. And now let's try to verify it. Oh, not another problem. I've got a bad arc. Line 19, it says that there's a bad arc. When you get a bad arc, one of 3 things has occurred. Either the end point, the XY value that the student has put in is incorrect, the IJ value, the center around which that arc swings, is incorrect, or the machine is set up to do arc centers incremental, which is not what we want. So the first thing I'm going to check is go to Setup, Run Settings, and yep, arc centers incremental is checked. If I uncheck this, when we write code by hand, that has to be unchecked. When EdgeCam writes code for us, it has to be checked. The last program I ran had an EdgeCam program, so therefore that was checked. By unchecking it and saying OK, I might have gotten rid of my bad arc. Let's try it. I'm going to say go. Normal program stop. Uh-oh. Another error. It made an arc all the way around. When that happens, that means that the student does have an error on that line of code and the center for my arc is not correct, or the endpoint is not correct, and the students need to go back and fix that before they can actually run it on the machine, because otherwise this is what you're going to get. We'll say OK. Another problem that I have, and this is getting kind of messy now, so what I'm going to do is I'm going to say Window, Run and Edit, pop everything back where it belongs, and notice I'm using tool 1. It's a very, very tiny tool. You can't even see it here. It's a 1/16th tool, if you remember correctly. I can also go in here and change that now to say tool 3, which I know is a 1/8 inch end mill. If I go to Tools and set up my library, I look and I see I have tool 3 is an 1/8 inch ball mill. I can now say OK, and if I verify it, let's see what happens, other than my bad arc. And so now I have a nice bold letter. I'm going to go back to Run and Edit screen, and really, so some of the main errors that you can have, make sure there aren't any spaces inside between the X and the 0.5 or the Y and the 1.5. Make sure that zeros are zeros and not O's, and also when you start doing arcs, make sure that the student has the right X, the right Y, and the right I and J values. Otherwise, you'll get the bad arc. It can't be run with the bad arc. And that's how you verify a program. Okay, I've gone in and I fixed all the errors. Now let's make sure that this will correctly verify. I'm going to swing this up here and open it up so that we can see it, and now I'll verify it. Verify program, insert tool 3 now, go. Normal program stop. That means it went all the way through the program. I can see what it looks like, and it's going to work just fine. Another thing that I can do is when I'm all done, I can say program. I can estimate the runtime, and it'll estimate it's going to take 1 minute and 1 second, and the distance the tool is going to travel is about 17.7 inches. That's good to know, and kids like to make a contest out of it and see how fast they can make it go doing their letters by changing the order in which they do the letters, changing direction The only thing we don't let them mess with yet are speeds and feeds. And so that's how you verify it. If you wanted it to run as if it were going to run on the machine in real time, you can, instead of clicking on verify, you can click on run, and it'll go through. It'll just take that whole 1 minute it'll do, and you'll be able to see this move. If your settings are set up right, if your video card settings are set correctly, you'll be able to see the letters carved into this block here too.